The parent says, your geometry teacher thinks you need extra homework. The student says, tell her I want proof. Well, guess what? That's what we're going to go over now. Proofs that special parallelograms are special, that they're either a rectangle, a rhombus, or a square. So what are the conditions? We pretty much went over these in the last section, but let's go over them again. If one angle of the parallelogram is a right angle, then it has to be a rectangle. Remember, rectangles are equiangular parallelograms. Also, if the diagonals of the parallelogram are congruent, then the parallelogram is a rectangle. So congruent diagonals definitely means rectangle. For rhombuses, if one pair of consecutive sides of a parallelogram is congruent, that would mean all four sides are congruent. So that would be a rhombus. If the diagonals are perpendicular, then that would also make it a rhombus. And if one diagonal bisects a pair of opposite angles for a parallelogram, then it would be a rhombus. Now remember that squares have to meet conditions for both rhombi and rectangles. So let's look at example 1. I'm going to use diagonals, notice they say diagonals, to determine whether this is a rectangle, rhombus, square, or neither. So I'm going to give all the names. And I went ahead, this is not exactly accurate, but I didn't give you any graph paper, I should have. And I just plotted the points in order A, B, C, D. Because when they give you a parallelogram, they usually give you the points in order around the edge. And the first thing I'm going to do is compare the slopes of AC and of BD, the two diagonals. And I find out that the slope of AC, I use y2 minus y1 over x2 minus x1. So 2 minus 4 over 4 minus negative 10. And I get negative 2/14, or negative 1/7. Then I find the slope of BD, the other diagonal, and I get 10 minus negative 4 over negative 2 minus negative 4, which is going to be 14 over 2, and that's 7. These two slopes are negative reciprocals. That means those segments are perpendicular. If the diagonals are perpendicular, that's automatically a rhombus. Now I'm going to check and see if I can make it a rectangle. So I found the distance of each diagonal. For AC, I used the distance formula. Just said x2 minus x1 and y2 minus y1 and squared those. So I'm doing AC, so I have 4 minus negative 10 squared and 2 minus 4 squared. So that's 14 squared plus 2 squared, 196 plus 4, 200. So this distance is square root of 200. Now I'm going to find the length of diagonal BD. Use the same formula, and in this instance, even though it's two different points, I got the same answer. Since the diagonals are congruent, it has to be a rectangle. Since it's both a rectangle and a rhombus, this also qualifies as a square. Now in problem 2, it really would have helped to give you some graph paper on this one, but I roughed it with you. I just went ahead and drew it myself. Now this is line AB, there's CD. For a parallelogram, remember you assume that it goes in order. So I went ahead and used this slope to find the next point. Let me go ahead and get my pointer. And basically I noticed that this went up 1 over 7. So I went from point A and I kind of went up 1 over 7. So that gave me that point there, which is 2, 5. 2, 5. Let me use my pen, that'll be faster. So 2, 5. All right? And I'm saying that this is automatically going to be a parallelogram. Even if you count these points right here, 2, 5, you'll find out that this comes down 5, this goes over 5. This also comes down 5, and this is over 5. So opposite sides are parallel. And so since the opposite sides are parallel, we know it's a parallelogram. So we at least found our point, so it's a parallelogram. Now can we say it's a rhombus? Well, I only have to show that two consecutive sides are congruent. So I'm going to do side AB and side BC. Not opposite sides. I need to show consecutive sides. So I use the Pythagorean theorem to find the length of AB, and I find out 5 squared plus 5 squared, 25 plus 25, 50. Since I want to find AB, that's going to be the square root of 50. Then I find the length of BC using the same formula. That one you can see the length is 7 on bottom and the height is 1. So 1 squared plus 7 squared. Using the Pythagorean theorem, I also get square root of 50. Well, if the diagonals of the two consecutive sides are congruent, then and it's a parallelogram, it has to be a rhombus. In example 3, we're trying to complete we're going to actually prove theorem 652. The theorem is, if something's a parallelogram, in this case EFGH, and if the diagonals are congruent, then it has to be a rectangle. So how can we prove that's true? Well, first of all, here's the given information from the proof. Then they say EF is congruent to HG. Well, this is a parallelogram, so I know opposite sides are absolutely congruent. Then we're going to use a reflexive property to show that EH is congruent to EH. Now they say, okay, I can tell you that a triangle EFH, this one right here, is congruent to triangle, and I'll change to different ink, pink maybe, or green, is congruent to triangle HGE, this one right here. Well, how do they know? We know the diagonals are congruent, we know the opposite sides are congruent, and by the reflexive property, this is congruent. So by side, 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 we know those two triangles are congruent. Now they're going to tell me that angle, let me get my pen, they're going to tell me that angle FEH, so that's this angle here, is congruent to angle GHE, which is this angle right here. And how do I know that? Well, those are corresponding angles of congruent triangles, and those have to be congruent. CPCTC means corresponding parts of congruent triangles are congruent. Now, I know that these two are supplementary because consecutive angles of a parallelogram are supplementary. Well, since these angles are supplementary and they're congruent, they have to be right angles, because the only way for two angles to add up to 180 and be equal at the same time is if both are 90 degrees. Now I can say that EFGH is definitely a rectangle, because a rectangle is a parallelogram with one right angle. For example 4, I went ahead and I already graphed these lines down for you. The way you graph y equals negative x plus 1, here you go. It goes through 1 and the slope is negative 1. So there's 1 point. I can also go backwards. Make sure that the line is going down. Now I can also, let me get my highlighter. Oh, that's ink. And what I'm going to show is the other point, if I can. There we go. Pointer options, ink, and stick back to the yellow. This line right here is y equals negative x plus 7. So these two lines have exactly the same slope. You can see that they both have a slope of negative 1 just by the coefficient of x. So those two are parallel. The other two lines, y equals 2x plus 1, starts at 1, it has a slope of 2. There it is. And that line is going to be parallel to line P, which is y equals 2x plus 7. So, in color, I'll just go ahead and do it like that. So you can see that this one right here and this one right here are parallel. Well, since opposite sides are parallel, this is automatically a parallelogram. Now, one thing I can tell is that the slopes are not negative reciprocals of each other. The negative reciprocal of 2 is negative 1/2. So this would not work for a perpendicular line. Since the sides are not perpendicular, it is not a rectangle and it's not a square. So the slopes of opposite sides are the same and the lines are parallel. And I didn't really bother to find the lengths of these two sides to see if it was a rhombus, but it's pretty obvious from the picture that they are not equal. So you could have found the lengths using the Pythagorean theorem. Now in the last example, we're going to see what do we need to do to conclude that this is a rectangle. How can I prove that? So I'm going to list each of the points and what they tell us. We do know that PR and QS intersect at T. So T is right there at that intersection. The first one says PT is congruent to QT. Since we know diagonals bisect each other on parallelograms, then that would mean if that's a halfway, this one would be half of that. So this is half of the whole. And this is half of the whole. If those two pieces are the same, the wholes are the same, so the diagonals are congruent. Then they tell us that PT is congruent to RT. PT is congruent to RT. Well, that tells me that QS bisects this one, but I'm not sure I'm going to get a lot of information there. Then I know that PT is congruent to QT. PT is congruent to QT. Well, hold on. I have the wrong thing. PT is perpendicular to QT. Change that. Not congruent, but perpendicular. That would mean the diagonals are perpendicular. That would be true for a rhombus. And then finally, PT bisects angle QPS. Well, diagonals bisect the angles for all parallelograms, so that doesn't really narrow things down for me. So D is no, doesn't narrow anything down. C is diagonals are perpendicular. That's true for a rhombus, but not necessarily for a rectangle. So that doesn't help. One diagonal bisecting the other, again, not very helpful. So my actual answer, if the diagonals are congruent, that's all the information I need to show that this is a rectangle.